Welcome to your first Getting Ready tutorial. In this tutorial we're going to discuss adding real numbers, including those with decimals, simplifying fractions, multiplying, dividing, and adding fractions. So let's get started with adding some real numbers. So for example, we can start with a simple example of adding 9 and 7. These are two real numbers, and we've probably all done a problem like this before. And we know that when we add 9 and 7 we get 16, which seems relatively simple. However, there are a few things that we want to be careful of. So for example, let's say we want to add 9 and the real number -7. In this case, the second digit is negative. So it's the same as saying 9 minus 7. So we're taking 7 away from 9, which gives us the value of 2. Now, what if we reverse the situation and make this -9 plus 7? Now the negative's in the first number. Again, this is the same as 7 minus 9. And now the number we're taking away is larger than this number, so we'll get a negative number here. We'll end up with -2. And we can also have a case where we've got both digits being negative. So -9 plus -7. So in this case we end up with -9 minus 7. And a great way to think about this, if you're not sure, is to look at a number line. So here's a number line. Here's -9 on the number line. And below it would be -10, and then -11, and so on, -12, and so on. And we're starting here at -9, and we're moving down this way. So we're moving in a negative direction, 7 digits. So if we move from -9 down 7 digits, we go to -10, -11, -12, -13, -14, -15, -16 would be the correct answer here. Now, we can also do this using decimals as well. So let's try some examples with decimals. 1.2 plus 6. So only one of the numbers has decimals here, and I always find it helpful to write this out in a vertical format so that I can keep all the places straight, because remember, we have to keep all the places straight when we're adding. So here, anything after the decimal I should add in the correct places. So I'll add 2 and 0 and get a 2, and I'll add a 1 and 6 and get a 7. The answer here would be 7.2. Let's try one that has two numbers with decimals. So let's try 3.4 plus 1.8. And again, I'm going to write this vertically. 3.4 plus 1.8. 4 and 8 is 12, so I'll put a 2 here and carry the 1. 3 plus 1 is 4, plus another 1 is 5, so 5.2. And all the same rules apply that we talked about over on this side. So if I have 3.4 plus -1.8, this is the same as 3.4 minus 1.8, and now I'm subtracting. So here I'll need to borrow. So 14 minus 8 is 6, so I have 0.6 here. And 2 minus 1 is 1, so 1.6. And now let's move on to simplifying some fractions. So for example, I can have the fraction 2 over 5, which is in its reduced form. So I can't reduce this any further because there's no common multiples in 2 and 5. But if I have the fraction 2 over 10, now there is a common multiple between 2 and 10. It's actually 2 here, so I can reduce it. If I divide the top and bottom by 2, I can reduce this fraction. So 2 divided by 2 is 1, 10 divided by 2 is 5, so I get 1/5. And similarly, if I have the fraction 7 over 21, these both have the number 7 in common, so I can divide both top and bottom by 7 and get 1 over 3. So these fractions are simplified. Now we can also work on adding fractions or multiplying and dividing fractions. So let's start out with adding some fractions with the same denominator. Remember, the denominator is the number in the bottom, the numerator is the number in the top. So let's start with 2/5 plus 1/5. And when we have a common denominator, as we have here, the same denominator, that stays the same in the answer, and we simply add the top two numerators. So 2 plus 1 over 5, or 3 over 5. We never add the denominators here. Now, that's different from if we're multiplying. So if we're multiplying fractions, 2/5 times 1/5. In this case, we multiply both the numerator and the denominator. So we get 2 times 1 over 5 times 5, which is 2 over 25. Let's try another one of those. 3/7 times 5/4. So in this case, we don't have a common denominator, but that's okay, because when we're multiplying, we just multiply the two numerators together over the two denominators multiplied together. So we end up with 15 over 28. Something similar happens when we're dividing, but we have one important rule to remember. If I am dividing 2/5 by 1/5, I need to remember to multiply by the reciprocal of the second number. So 2/5 divided by 1/5 is the same as 2/5 times, and I invert this to be 5 over 1. So I make this a multiplication problem, and now I have 2 times 5 over 5 times 1, which would be 10 over 5. Which in this case we can simplify because we can divide both top and bottom by 5, and we get 2. Let's try one more example here. 3/7 divided by 5/4. And now I'm going to run out of room, so let me get a new page. So again, 3/7 divided by 5/4 will be the same as 3/7 times 4 over 5. We invert and multiply by the reciprocal, which will be 3 times 4 over 7 times 5, or 12 over 35. Now that you've seen some of these examples of the problems, go ahead and move on to your getting ready for Chapter 2 homework.